Okay, guys, we are starting. Really, we need to be in the seats when the bell rings. Want to finish? Okay, I have what? Okay. Um, we're gonna start with. It's actually a three-part do now. Okay, and they're all based on the first fundamental theorem of calculus. Now, when I say they're all based on the first fundamental theorem of calculus, remember that tells us that whenever you integrate the function, now I'm going to write f prime of x just for this case, from a to b, when you take the definite integral from a to b of f prime of x, what would you get? Say it again. You'd get f of x for the antiderivative, and then you'd plug in b and a and subtract, so what do you get? F of b minus f of a. And so if we get f of b all by itself, f of b, the y coordinate on the graph of f when x is b, what does it equal? F of a, good, keep going, plus that, plus the definite integral of the derivative of that function from a to b. So it's not something like, oh, I got to memorize that. You can always figure it out, but it really does come up a lot on the AP exam. And you don't always need to use it, as in the first example. Here in the do now, I give you the derivative of a function, 2x. And I give you that g of 1 equals negative 2. And I want you to find g of 3 and g of negative 2. So I want you to apply this. So like define g of 3. Your b would be 3. And what are you going to use for your starting value? Yeah, you'll use g of 1. So try to write out, g of 3 equals g of 1 plus the definite integral of the derivative which you're given, and work it out like that. Do both of those. Start with that one. If you can, try the second part when you're given the graph of the derivative. It's the same question, but instead of being given the actual derivative, you're given just the graph of the derivative. You got it now? Good. Yes. Yes. Okay, so let's talk about these. Let me just put this. Well, I'm going to talk about the alternative solution in a minute. Where's my things? It's under here. Okay. Let's just talk about how to get these. So if we want to use this, g of 3 equals g of 1 plus the definite integral from 1 to 3. When you first write it out, don't change the first fundamental theorem of calculus. The number in here matches the one down here, your a value, and then you have a plus in front. Okay? And so you get the antiderivative of 2x, which is x squared. Plug in the 3, the 1, subtract, and you get 6. You do the same thing to find g of negative 2. Start with the point you know on the graph of g. Start with g of 1. So then you'd have to add the change in g by adding the definite integral from 1 to negative 2. And I love that you guys knew, like you felt, oh, there's something wrong when that lower limit's not less than the upper limit. That's great. And if you did switch it, and as long as you made it minus, you would get the right answer anyway. You could always do it. You could always make it minus the definite integral from negative 2 to 1. But what I'm saying is you don't have to unless you're using a graph to get the value of the definite integral. So just like before, you get the antiderivative, which is x squared. You plug in the upper limit, the lower limit, and subtract. And your answer should be 1. Breathe like that. That's going to come out really loud. All right, any questions on these two? So if you're, anytime you're just given the derivative, and you're given a point on the function and you want other y values, this is one way of doing it. But did anyone think of another way they could have found these values? You're given g prime of x. What were you thinking here? Okay. Perfect. If I hadn't talked to you about this just before the do now, and you had a little chance to think about it, I bet you would have thought, all right, well, if g prime of x is 2x, I can just get the function, right? You know how to go from g prime to g. You take the antiderivative, but that gives you a plus c, right? Use the point that they gave you, the 1, -2, to find the value of c. Now you've actually got g of x. You could plug any number you want in. You could plug in the 3, you'd get the 6. You could plug in the -2 and get the 1. And you can always do this as long as g prime of x is something that you can find the antiderivative of. You see how that works? But you're not always going to be able to find the antiderivative of g prime. That's why I want you to be aware of this technique. So this case, either way, it's good. Let's look at the second case. It's really the same problem. I still tell you that g of 1 is -2, but instead of telling you that g prime of x equals 2x, I've just given you a graph of g prime of x. And I want you to find g of 3. Now, you can't just, unless you know that equation, let's pretend you don't, you need to use the graph. You have to do it this way. So let's just do this one together. If we want g of 3, what do we start with? G of 3 equals g of 1 plus the definite integral from 1 to 3 of g prime of x. Oh, and I don't know what it is, so I'm just going to write g prime of x. So g of 1 is -2. But my question to you is, if you don't know what g prime of x equals, you just have a graph of it, how do you get the definite integral of it from 1 to 3? Area. Okay, so you look at this, you take the area above minus the area below from 1 to 3. Okay, here's 1, here's 3. It's all above. And Ryan, you're right, it's in the shape of a trapezoid. So the definite integral from 1 to 3 of g prime, it's just this area between the graph of g prime and the x-axis. I don't have to subtract any of it. There's nothing below the x-axis. So let's just figure out the area of that. We could use a triangle and a square, or we could use the area of a trapezoid. Trapezoid, right? Might as well practice it. Do you remember the area of a trapezoid? Yeah, one half the sum of the bases times the height. Let me just write that down. So it's 1/2 the sum of the bases times the height. The bases are the parallel sides. So what's the length of this base? 2. And what's the length of this base? 6. So it's 2 plus 6 in there. The sum of the bases. What about the height? 2. It's the distance between the bases. So that's 2. And I hope we get the same answer. Do? Crazy. -2 plus 8 is equal to 6. See, this time I just gave you a graph of 2x instead of telling you the derivative was 2x. So we know what the answer is going to be for g of -2. I could have sworn she was looking at the phone, but she's not. All right, g of -2. Let's see how we would get it. So to get g of -2, again, what would we start with? G of 1, because we know that 1. Now let's write down plus the definite integral from 1 to negative 2. See, now your concerns are valid. Now, if I'm going to use area to get the value of a definite integral, the lower limit has to be less than the upper limit. So we are going to switch them now. So when you switch the limits of integration, great, you have to negate it. So it's g of 1 minus the definite integral from negative 2 to 1. Oops. Okay. Now I know to get the value of a definite integral from a graph, I have to do area above minus area below. I'm just going to write that down. When I say below, I mean below the x-axis. Okay, we're going to look at the graph, and this is from negative 2 to 1. So we want to get between negative 2 and 1, we want to find the area above. Now the area above is the area of this little triangle up here, minus the area below. So, let's get the area above. What's the area of this triangle here, the area above? 1/2, 1 times 2, which equals 1. Right? Area of a triangle, 1/2 base times height. So it's 1/2, 1 times 2. That's 1. Now let's get the area below, the area of this triangle here. Alright, that's enough. Too bad Sydney's not here. That'd make her crazy. Alright, what's the area of that triangle? 1/2 base times height. 1/2, 4 times 2. What's that? 1/2 of 8, which is 4. Right? So what's the value of the definite integral from negative 2 to 1? If I do area above minus area below, 1 minus 4 is negative 3. Right? I'm going to put that in here. So g of 1 was, I forgot, that was negative 2. Minus, it was area above minus area below. So it's minus negative 3. So we get negative 2 minus negative 3 equals 1. Oh my gosh. Okay, the very last thing just takes a second. And this comes up a lot too in the calculator section of the AP exam. Anyone need a calculator? I have some here, if anyone needs a calculator. Do you want a box of raisins? Okay, does anyone need a calculator? So, remember when we did that first one, we had the derivative was 2x, and, we had a point on the graph, and we really had the option. We could have just found out what the function was. But in this case, there's no way we could figure out what f of x equals, because in order to try to find the antiderivative of sine of x squared minus ex, I would need u substitution. And I don't have the vital ingredients for du. I would need a 2x minus e to the x sitting next to it. Then I could take the antiderivative of sine u du. But I don't have that, so I could never do this one and figure out what f of x is. But with a calculator, I can find f of 3. We're going to set it up the same way, and you guys are going to tell me what to write. So here's the derivative of the function. That's the given value. So if you want to find f of 3, what are you going to start with? F of 1, right? Because that's the one they gave you. 1 to 3. So it's plus, and the lower limit has to match this number. 1 to 3 of that. That's the derivative. So I'll write that down. So f of 1 we know is 5. We can go right to the calculator, and we can actually plug in 5 plus math 9, F-N-I-N-T. We'll put in our function. Make sure you're in radian mode unless you want to be, comma x, and then it's always lower than upper on the calculator. 1. So we put in 5, because that's what f of 1 equals. Let me know when you got something for that. Would get. No, you're wrong. Someone gets a positive. Oh, wait, let's hit negative. What if I'm wrong? I might be wrong. Well, negative what? No, you're wrong. What'd you get? 4.06? Oh, 4.60. Yeah, that's the right one. What? All right, I'll show you. On the calculator, you'd have to put in 5 plus math 9. Are you in radian mode? Oh. You probably hit it and it didn't really press fully. That happens to me a lot. Oh, okay. Well, you didn't have to say that. So this f of 3 should equal this number right here. 4.6. 4.8. I think I got that when I didn't have a plus, and because it's a minus. I did that the first time when I was up because I forgot the problem. Now, when you have to go find f of 0, it's going to be the same thing. You just want to change the 3 to a 0. So you know you can hit second enter and bring it all back and just change the 3 to a 0. You don't have to retype the whole thing in. When you have something up there and you want it to come back so you can edit it, you just hit second enter. It'll all come back and just change that 3 to a 0, and you should get 5.96, this number here. Well, for the f of 3, you should have 4.602. But then when you want to find f of 0, you can do the same thing, but instead of a 3, you have a 0. So it should be 5.96. What? Okay. All right, so let's get back to what we were doing. Well, actually, I want to go over the homework. I'm going to do that. Okay, number 2. So you're told that h of x is equal to the definite integral from 1 to x of f of t dt. And this is the graph of f. And what do we say you always do when you're given an accumulation function? Take the derivative. So you have to realize that h prime of x is f of x. Oh, it's what you're looking at. That's so important, you're not going to know where to start. Okay, so once you identify that, the first thing they ask you is, why is it acting so weird like this? Find h of 1. If h of 1 would be the definite integral from 1 to 1. Did you get 0 for that? It should be 0. Good. Because the lower and upper limits would be the same. For h prime of 4, we did this already? Oh, you got that? That is a graph of h prime. So you just read the graph. You just look at the graph. When x is 4, what's the y coordinate? Oh, it's 2. You got that? Okay. And it says on what interval or intervals is the graph of h concave up? So in order for h, the graph of h to be concave up, what has to be true about the first derivative? Because that's what you're looking at. Yes. Increasing. So you want to say from 1 to 3, oh, and 6 to 7. I don't know. You're not touching anything, right? There's nothing? Just checking. She might be touching. Okay. As far as including the 3 or the 6, it doesn't matter. Because it's really, at 3 and at 6, it's not increasing or decreasing. It's just a stationary point. So it doesn't matter if you include them. Because that's where h prime is increasing. And when h prime is increasing, h will be concave up. Okay, this one was tricky. I love this. I definitely want to discuss part D. Find the value which it has the absolute min. It just says min on a closed interval, so they're talking about the absolute min. So you look at the graph. First of all, does it have any relative mins? Does h have relative mins if that's the derivative of h? No, right? Because the derivative never goes from negative to positive. So there are no relative mins. The derivative is positive, so h is increasing, and then it's negative. H is decreasing. So there are no relative mins. So where would the absolute min have to occur if there's no relative mins? Either where it starts or where it ends, at the beginning, at one of the endpoints. Anytime you're asked for an absolute extrema max or min, it can either happen at an endpoint or at a relative max or min. So since there are no relative mins, the absolute min must occur at an endpoint. Now we know what h of 1 equals, right? H of 1 is 0. But if we want to get h of 7, if we want h of 7, we would have to get the definite integral from 1 to 7. You can't get what it is. But how do you find the definite integral from a graph? Area above minus area below. When you look at this, between 1 and 7, if I could scroll up, I would. Is area above minus area below going to be positive or negative? Positive, because there's much more area above than there is below. So you know it's a positive number. I don't know what it is, okay? But I only have to compare these two values. I'm looking for the absolute min. So I'm looking for the smallest of these values, of 0 or some positive number. Where does the smallest value occur? At what x value? At 1, because 0 is going to be less than any positive number. So again, we know that this is positive, and if this was the AP exam, I would say by comparing the areas. That's all you would have to say. By comparing the areas. You know, if you want to you always got to justify things. That's what I put here, right? So yeah, we know an absolute min can only occur at either an endpoint or relative min. There are no relative mins, so we check out the values of h at the endpoints. At 1, we knew it was 0, and at 7, we just knew it was positive because there was more area above the x-axis than there was below. So the absolute min has to be at 0. Those are the only choices. Oh, I said 0 and it's 1. Whoops. At 1. That's the other endpoint. Thanks. All right, yeah, that was good. Yeah, well, wish I'd said something. Okay, we okay with that? I'm sorry. Right, let's check out the other one. Number 3. So 3, you had to get some areas in this one. You did have to get the area of this quarter circle in here. So you could get the area of the whole circle, pi r squared. So pi times 2 squared would be 4 pi would be the area of the whole circle. So 1/4 the circle would have an area of just pi. So this area is pi. The area of this triangle is just a half. Down there would be a half. I mean, we'll get the others later, but I just wanted to make sure you saw that. So g of x is the definite integral from 0 to x of f of t. This is a graph of f. You take the derivative and you say, oh, that's g prime. You're looking at a graph of g prime. To get g of 3, it's the definite integral from 0 to 3. We look at the graph from 0 to 3, and we take area above minus area below. So it should be pi minus 1/2 for g of 3. B was like a fun problem. Find all values of x on the interval from -2 to 5, which g has a relative max. So what were you looking for? Positive to negative for the derivative. So hopefully you got x equals 2. And you want it, when they say justify, you have to say you have a relative max occur when g prime changes from positive to negative. You say g prime. Okay. love part C. Write the equation for the tangent line to the graph of g at x equals 3. Write the equation of the tangent line to the graph of g at x equals 3. So it's going to be y minus g of 3 equals, the slope is g prime of 3 times x minus 3. We already got g of 3 in part A. How do you get g prime of 3? Look at the graph. If you look at the graph, when x is 3, the y coordinate is negative 1. So g prime of 3 is negative 1. So y minus g of 3, y minus parentheses, y minus a half, equals negative 1 times quantity x minus 3. It's a standard. It's a classic, right? The equation of the tangent line. It's like that's the one thing you're going to be asked to do all the time. And then in part D, it said find the x-coordinate of each point of inflection of the graph of G. If you're looking at G prime and you're looking for points of inflection of G, max and mins, right? Because what you're looking for is the second derivative to change sign. Well, that's just the slope of the first derivative. So you can say, okay, it should happen at 0 and 3. Right? You have a max here and a min here. Because this is the first derivative, so its slope, this second derivative, is changing sign. At 0, it's going from positive to negative, the second derivative, and at 3, negative to positive. So you'll have more fun with the problems 1 and 4 tonight, okay? But we're going to get back to the giant problem. Does that sound good? We've got giant problems. I know I had a problem when I wrote that. Is that what you're making fun of me for? If you look on your paper. Yes, I know. You are. It says like something else on yours. Yeah, I think you did. It's spelled wrong in there. Now, I don't know how far we actually got on this problem. So about D? Nice. Okay, we are up to E. So I'm going back to day 83. What's that? When I said problem, is spelled. I had problems. Problems, or whatever I said. Okay, so we're back to this gigantic AP type problem, where we're given the graph of f, and we're told that g of x is equal to the definite integral from negative 3 to x of f of t. So the graph, so what is g prime equal to? F of x. So we're looking at a graph in this problem of g prime. This is the same thing, f and g prime. Part E. Where does the absolute max of g occur? Well, where could it occur? Say it again. Yes. The absolute max can only occur at one of the endpoints or a relative max. Does this have a relative max? Where? At 3. So the only x's we have to consider, so we're going to have to compare the values of, this is called g of x, negative 5 at 3, because that's where the derivative changes from positive to negative, and at the other end, 0.4. So we're going to have a lot of definite integrals to find values of g, which means we have to calculate areas. Now, I don't know did we calculate the areas of all these little sections yet? We got this one, right? 4.5? Or, well, let's figure these out. What would this area in here be? 1/2 base times height? 1 half, because it's 1/2 1 times 2. What about this area down here? It has to be the same, right? 1/2 1 times 2. Ugh, we gotta get these guys. We'll get that in a second. What about the area of each of these little triangles? 1/2 1/2. I'm going to write 0.5. Might be a little easier for me. But I still have to get the area of those in there. So to get the area of this thing, what would our strategy be? You played with blocks. You know those blocks, you have that shape, and then you got the other one that goes in it, right? So you would take the area of the rectangle, right? And then you're going to subtract the area of the semicircle. Alright? Have you all seen those blocks? I said y'all, I sound southern. Alright, so what would the area of the rectangle be? 2, right? 2 times 1. We have to subtract the area of the semicircle. You can either do 1/2 pi r squared or pi over 8d squared. Semicircle. You can do 1/2 pi r squared. 1/2 pi. What's the radius if we saw the whole circle? 1. So it's 1/2 pi. So I'm going to write pi over 2 in here. Can I fit that? So the area of these two pieces together, this guy and this one, that all adds up to 2 minus pi over 2. Alright, now we're all set. I can do this. But I do have to erase all this. Alright, so g of -5 would be the definite integral from -3 to -5. Uh-oh, I'll have to switch that. Of f of p dt. Sorry, that's not his. Can't fix it. So you would, if you're going to use the area to get that, you would have to switch the limits because you want -5 to be less. But in this case, it actually doesn't matter because look at area above minus area below between -5 and -3. 0. So yeah, I would switch them, but then I'd have -0, so it's still 0. Because I used the definition of... Oh no! Wait a second. Oh, there we go. There we go. Oh, I have to get it exactly. Oh, nice. Good. Nice. Yeah, I use the definition for g of x. So, like, if I want g of 3, I take the definite integral from -3 to 3. So now we got to look at this graph between -3 and 3 and give area above minus area below. So, from here to here. Oh, it's all above. So we just got to add these up. The 4.5, the 2, the 0.5, and the minus. All that. Seven minus pi over 2. And what about g of 4? That's the definite integral from -3 to 4. Say it again. 6.5 minus pi over 2. Just 0.5 less. So which of these... Oh, where does the absolute max occur? Compare the y values. 3. So the answer for this is x equals 3. And then when it says, what is the absolute max? 7 minus pi over 2. So we will continue this tomorrow. Try 1 and 4. Do the best you can. Don't forget about your guide. Here's the guide. Did you read the guide? Oh, there's a guide in there.